Hello students. So in this video we are going to see the other 2D transformations. Actually this is also continuation of the previous video only. So far we have studied different transformations and inverse transformations and all the homogeneous coordinates, right, and composite transformations. So in this video we are going to cover other 2D transformations and what are the different raster methods are used for the geometric transformations, then the raster transformation, right? So in the previous video I said there are two different types of transformations are available. One is geometric object transformation and another one is raster transformation, right? And finally the different functions which is used for the geometric transformation, right? So let us start with other transformations. So the very first other transformation other than translation, rotation and scaling is reflection. Okay, so the reflection is otherwise known as mirroring of the particular object, right? So here in this xy plane, a reflection of an object triangle about x-axis they have shown, right? So the original position consists of three different coordinates 1, 2 and 3. So how it is reflected in the other quadrant. Okay, so in the circle drawing algorithm we have studied about octant as well as quadrant of the 8 symmetry property, right? So here the reflection actually here we are using that symmetry property only. So here 1 will become 1 dash and 3 dash and 2 is a 2 dash, which is nothing but the reflected position of the original object, right? So here the reflection of x-axis means actually what we are doing in the y-axis actually it became a negative. X-axis anyway there is no change, the same x-axis values only we are using, right? So 1 0 0 and 0 minus 1 0 and here we are using a homogeneous coordinate, so 0 0 1, right? So this is the matrix format for the reflection, right? So this is about x-axis and y-axis. Y-axis means the x value. Okay, the x value there will be a negative, y value will not change, right? So here this is the original position of the triangle. So if it is reflected to this area, then we will get 1 dash, 2 dash and 3 dash, and the corresponding matrix is minus 1 0 0 and 0 1 0 and 0 0 1, right? So here this part is called as all positive coordinate point, and here we will get now y as a negative, right? And here also we will get x as a negative, and this area, this quadrant is both the values are negative, right? So according to this symmetric property we are just getting the reflection of the particular object, right? And this is the reflection of an object relative to the origin. So here this is the origin point. Okay, so this is all positive point and this is the negative area, right? I said this is the negative area, means both the x as well as y values will be negative, right? So just if you are doing the reflection means all the x and y value will be negative, means reflected the way how we are doing the original image with the reflected position, right? And this is another one example with respect to the line. See, reflection means not only the quadrant within the octant also, right? So octant means see one quadrant is having two different octant. Okay, so this is the first one and this is the second one, right? And here x equal to y, right? If you want to get the reflect position over here means just we are swapping the value x equal to y as well as y equal to x, right? So in this way we are getting the reflection of a particular object. And in the other transformation the next type is called as shearing, right? Shear. So shear is nothing but the distortion of the shape of an object. Okay, so the shear is used to distort the particular shape of the object. For example, if we are giving the square or rectangle means we will get parallelogram, right? See here in the example they have given unit square, but what we are getting as a parallelogram. Okay, So this kind of transformation means just we are distorting the shape of an object, right? And this kind of objects will be composed by the internal layers that will be caused by any of the side over with each other. For example, see here x value they have not changed. They have changed only the y value, right? So with respect to y, with not y value, with respect to x value only we are doing the shearing, right? See here it is the values are 0 and 1, here it is 1 comma 1, right? So with respect to shx, so we are adding 2 x value equal to 2, so that we are just distorting the object. So instead of 0 1 and 1 1 we are getting 2 1 and comma 3 1, right? So this is another one transformation. So far we have studied translation, rotation, scaling, reflection as well as the shearing, right? And this is the summary of all the OpenGL geometric transformation functions, right? So here what and all geometric operations we have studied so far, everything will be specified in the OpenGL function. GL translate, so here it will be specifying all the parameters, translation parameters, then GL rotate and GL scale, okay? And next GL matrix mode. So this is very, very important, right? The function which is used to specify the current matrix of the geometric viewing transformation. Okay, so by using this matrix mode only, we are just adjusting all the projection, viewing transformation, and all the color as well as the attribute transformations, right? And next one is GL load identity. So which is used to set the current matrix to the identity matrix. Okay, and next one is GL load matrix and GL multi matrix. Okay, so which is used to set the elements of the current matrix, and this is the post multiplication of the values with the specified matrix, right? So these are the related geometric transformation functions. And next we are going for the raster method for geometric transformations. Okay, so first of all, the raster systems are nothing but which is used to store the information as a color pattern, correct? So whenever we are telling about a raster system, we should remember the frame buffer. So frame buffer is nothing but it is a combination of zeros and ones, right? So each and every pixels can be having different color values. Okay, so this raster system is used to store all the information, picture information in a frame buffer, zeros and ones, right? So suppose sometimes what will happen means some simple object transformations will be carried out very fastly by manipulating the array of pixel values. Okay, because again and again we have to refresh the screen to change the next scenes or the screenshots, right? So very rapidly it will happen. So few arithmetic operations are needed. Then only the pixel transformations are particularly efficient, right? So here what is raster method means? Functions which is used to manipulate the rectangle pixel arrays are called raster operation. Okay, and here we are moving a block of pixel values from one position to another, that can be called as a block transfer or a bit split, right? So this is called as the raster method for the geometric transformations. And some OpenGL raster transformations functions we are going to see. So the very first function is GL copy pixels. Okay, so the GL copy pixel is used to used to adjust the screen. Okay, x min, y min, width, height as well as color. Okay, and next if you want to translate any of the object means by the time we will be using this GL copy pixels only, right? And next one is GL read pixels. So the read pixel is used to read the particular raster characters. Okay, so here also we have to specify the x and y minimum value, width and height of the screen, and the color of the text, and what byte means, what unsigned byte, for example welcome or happy morning or some message, right? So that message color along with its color array, right? So this is the way of the OpenGL raster transformation to read or to write the particular bytes, okay, to read the pixels. And next one is for the rotation. Okay, so for rotation, GL draw pixels of width, height, and color, and along with the unsigned byte and color array. Okay, so this is used to draw the pixels. And finally, the scaling operation. Scaling can be done very easily by using the GL pixel zoom. Okay, so if we are zooming means then we can enlarge the particular pixels, correct? So these are the different OpenGL raster transformations. I hope you have understood all the transformation concepts, normal transformation, homogeneous transformations, then the inverse transformations, composite transformations, then two different examples, pivot point translation as well as fixed point translation, and finally other transformations we have discussed, shearing operation and reflection, and the raster transformation, and what are the different OpenGL functions are used for the transformations, right? I hope it is clear. Okay, thank you.